Okay, Bismillah. So the discussion for this one, for Sem 1 exam, number 1. So we have object moving in a straight line through air. So it can be that the object is moving horizontally or the object is falling. Okay. So when it accelerates, so this one is from equation F equal to ma. So if a is not 0, so the force is not 0. When it moves at steady speed, the air resistance acting on it is 0. Not necessarily. See, when it moves at steady speed, the resultant force acting on it is 0. So at steady speed, F equal to ma. So steady speed A is 0. So resultant force is 0. Okay, when it moves, there is resultant force. Not necessarily, because if V is constant like C, so A is 0. So F resultant is 0. Right, number 2. Which diagram shows forces X, Y with their resultant force? So A, we have X to the left and Y to the to up forward. So the resultant should be like this. Here the resultant should be like this, and the resultant should be like this. Number 3, a ball of mass, and then the velocity change from 0 to 5 in 0.6 seconds. So resultant force, so force equal to ma. So we need to calculate A equal to V minus U over T. So V is 5, initial velocity is 0, time is 0.6. So 5 over 0.6 is equal to 8.33 meter per second. So into here we can get the force. Right, number 4. The ball is at rest. Okay, so that means velocity is 0, and then boy kicks the ball in contact for 0.04 seconds. So this is time. The average force 200 Newton, and the ball leaves the boy at speed 20 meter. So this one is velocity. Right, so impulse on the boat and the average acceleration of the ball. So impulse, F equal to mv minus mu over time. Okay, so we have impulse. So this is not impulse is ft, so equal to mv minus mu. So force times time, impulse, and acceleration is v minus u over t. So F times T is 200 Newton times 0.04 second. Okay, so they will give us 8 Newton second. Right, and V is 20 minus 0 over 0.04. Okay, this will give us 500 meter per second square. Number 5. Okay, number 5. Okay, why this thing is moving? Okay, number 5 shows 3 forces acting on the object, so we need to find the resultant force. So to the left is 1, to the right is 9, so it becomes 8 Newton and 6 Newton. So the resultant force will be this way. So we have 6 8 sorry 6 to the above and 8 to the right, so it will become 10 Newton. Okay, number 6. Okay, number 6, we have constant force causing momentum. Which expression relate the force to the momentum and time taken? So force equal to ma. A is equal to v minus u over t. So we substitute into A. F equal to m v minus u over t. Okay, so we expand it, so force equal to mv minus mu over t. So mv is momentum, so this is momentum. Mu is initial momentum, so minus means change in momentum. So A. Number 7, so we have extension and we need to figure the value here. Alright, so with no load, this is the original length 15.2. Okay, so when we have extension 2.1, so length is equal to 15.2 plus 2.1 equal to 17.3 cm. Right, number 8, Hooke's law. Hooke's law, F equal to K times X. So F and X is directly proportional. So it's D. Dadu. Number 9, directly proportional. If like this, is inversely proportional. So here the equation will become F K over X. Okay, number 9. So we have a spring, load 400 Newton, the compression is 5 cm. So we need to find spring constant, F equal to Kx. So F is 400, K is unknown, X is 5 cm. So K equal to 400 divided by 5 is 80 Newton per cm. Number 10, spring constant K decrease when, so K, so like I draw initially, so we have spring, okay, so K increase when thickness increase or the length is shorter or the diameter here is small. Okay, so we want the K decrease, spring length decrease, wrong. Diameter of the spring decrease, this is wrong. Diameter of the spring wire decrease. Okay, the graph shows extension against force. Okay, which comparison is correct? P is softer. Okay, so we don't know the original length from the graph. What is the unit of friction? Friction is force. So force is Newton. Number 13, what are the three vectors P, Q, R acting on the car? So this is centripetal forces. So centripetal forces. Q is velocity. R is friction. Number 14, unit of moment of force. So like we have jongkang jongkit. So moment of force is force times distance. Okay, so Newton meter. So we have beam 5 Newton. Okay, so we need to find the weight, right? So as we can see, 5 Newton is a forward, anti-clockwise rotation, and the weight is clockwise. So 5 Newton times 2 cm, this is the anti-clockwise, is equal to weight times 5 cm. So the weight is 5 times 2 divided by 5, so it's equal to 2 Newton. Number 16, so we have jongkang jongkit P and Q. The mass of P is 25 kg, so the weight is 250 Newton. So we need to find the mass of Q. So again, 250 Newton times 1.2 meter is equal to weight of Q times 1.5. Okay, so weight of Q is equal to 250 times 1.2 divided by 1.5. Okay, so mass is equal to weight of Q divided by 10. Number 17, again we have beam and Q is lifted, so anti-clockwise, and of P remains on the ground. Okay, so G is the center of mass, so this one is clockwise. Here is the pivot. Okay, so we need to find the force. So force times 3 meter is equal to G, the weight, 600 Newton times 1 meter. So F equal to 600 times 1 divided by 3 equal to 200 Newton. Number 18, cutter to cut the rope. Where should be the rope position? Okay, so it needs to be closer to the pivot. Hand should be far. Okay, should be far. Right, number 19. So we have a hole. Where is the center of the gravity? So it will be in the middle. Okay, so we want to make it more stable. Heavy mass should be lower, and the base should be wider. Okay, what is the source of sun energy? So fusion. Number 22, so we need to find the center of the mass. So first we need to make holes around the shape, and then hang the shape. Make holes around the edge of the shape, and then hang the shape, hang the string from the pin, hang the shape. So number 2, number 3, and number 4. Right, number 23. So use solar panel should be at the equator. So dekat dengan garisan khatulistiwa. Number 24. So ultimate source of energy, not the sun. Okay. So horse is chemical energy from the sun. Hydroelectric, so hydro is from the rain, also the sun. So nuclear is from nuclear source, and windmill is also from the sun. First energy, so we have hydrocarbon plus oxygen, so this is combustion pembakaran. Okay, so it must be fossil. Non-renewable, so non-renewable is nuclear. Brakes, slowing down moving car, so kinetic energy into heat or thermal. Number 28, so we have energy conversion, so total amount is conserved, so it is principal conservation of energy. 29, so we have by riding bicycle, so this is the speed, the kinetic energy, calculate combined mass, so kinetic energy equal to half mv squared, so energy is 4250 joule times 1/2 mass times 10 the squared, so we can calculate the mass. Number 30, so we have motor energy, and useful is 450, so we want to find efficiency, so efficiency equal to useful energy over total energy 1000, total energy times 100. Okay, so it should be around 45. Common form is heat, right? Number 32, least efficient, not efficient, so it is the A, because it's using the filament. Filament produce heat, right? Number 33, so we have mass, so we have box lifted and it gains 100 joule of gravitational potential energy, and then it falls off, so at what speed? Okay, so gravitational potential energy change to kinetic energy. Okay, so kinetic energy is equal to half mv squared, so 100 joule of gravitational potential energy change to 100 joule of kinetic energy, so 100 to 1/2 times 8 times v squared. Number 34, so we have car, so kinetic energy 1.6 million, so accelerate for 20 seconds, so kinetic energy of the car increase to 2.5, so minimum average power developed. Okay, so power is equal to energy over time. Okay, so minimum average power is, so minimum average, so 1.6 divided by 20. So the average power in 20 seconds is 0.9 times 10 to the power of 6. total 45 kilowatt. Develop. Number 35. So we have difference in height. Okay. So lost gravitational potential energy, because here is high gravitational potential energy because it is at higher place, lower gravitational potential energy after it bounced. Okay, so we lost energy. So energy loss is energy cannot be destroyed, so this is wrong. So energy also cannot be increased. Internal energy. Increase means it change. So the answer is internal. Okay, so over here we have friction. So heat. Number 36. So we have mass and we have momentum. So find kinetic energy. Kinetic energy is equal to half mv squared. So is equal to half m times v times v. Okay, mv momentum is equal to 12,000. Okay, so we have mass. So mass is equal to 12. Sorry, we want to find velocity. So 12,000 divide the mass 1,000. So velocity is 12 meter per second. So we include back here. So kinetic energy is equal to 1 over 2. Mass is 1,000. mv is 12,000 and v is 12. Number 37. So we have ball at the top of the hill and then rolls down. At the bottom it hits the wall and stops. So energy changes. So it should start from gravitational potential energy to kinetic energy to internal energy. Right? Convert chemical energy to kinetic energy. Okay, so this one is movement. Okay, so movement, this is light. Okay, so car engine. So man climbs a ladder. Calculate useful power of the man. Okay, so we need to find power. Power is equal to energy over time. Okay, energy or work is force times distance. Okay, so force is the weight and time. So we don't have distance. Weight of the man and vertical distance, we don't have time. The work and the time. Okay, this one. Number 40, 50 kg mass, kinetic energy. So kinetic energy equal to half mv squared. So 81 equal to 1 over 2 times 50 times velocity. So we can find the answer. Alright, paper 4. Okay, so we have a ball 115 meter above the water. So we have the mass. So gravitational potential energy is equal to mgh. So mass is 0.16, g is 10 and height is 115. Number B. So when it falls off the cliff, kinetic energy will increase and gravitational potential energy will decrease. See? So speed time graph. So it gives us the gradient from 0 until 5. So from here to here, the gradient is 3 meter per second per second. Gradient here is equal to acceleration. So resultant force F equal to ma. So mass is 2300, A is 3. Okay, so that gives us the force. Explain the condition of the force after 20 seconds. Okay, so we can see that speed is constant, so that's the first point, speed constant. When speed constant, so we have balance force, and third point means force in equilibrium. Right, number 3. So solar cell. So advantage and disadvantage. Advantage can be it is direct current, renewable. Okay. Disadvantage can be need large space, expensive maintenance, and can only charge at day. B. Energy is realm. So nuclear fission and nuclear fission. So energy is released from the uranium is nuclear fission. Human created a lot of device. So sounds energy to electrical energy is microphone. Alright, Hooke's law. F equal to kx. So it is force is directly proportional to extension of spring. Alright, so we have force 120 Newton. So it extends to 64 millimeter. So force extension, so it is a straight line to 120, 110, 120, 64. So it is here. So it is a straight line like this. So spring balance, but the maximum reading is 150. Test his balance, non-weight 140, not 140. Why? Okay, so because the forces, it's only obeys Hooke's law until 120 Newton. So after this, it's not obey Hooke's law. Okay, so it will deform, change shape, not back to original shape. Alright, number 5. So we have a girl pushing a box, work. So we can use W equal to Fs, force is 200 Newton times distance 2.5 meter. Or we can also use W equal to Fs, 400 Newton times 0.75 meter. Okay, so 200 times 2.5 is 500 joule, and 400 times 0.75 is a long inclined plane, so we can only use 200 times 2.5 meter. Okay, B. So we have 20 seconds to the top of inclined plane. Calculate the average power. Okay, so power is equal to work or energy over time. So the energy calculated in A, 500 divided by 20. So that is 225 watt. Alright, thank you. You can contact me.